All right, welcome to this episode on how do we pass our common core algebra. How do we pass our common core algebra regions? And this time, we're going to continue with the quadratics. We're going to continue solving quadratic equations, but this time we are going to solve the quadratic equations using the quadratic formula. This quadratic formula will never let you down as long as you do it correct. You could actually input the whole thing in the calculator, but it's suggested that you start by doing each part first, okay? So, the quadratic formula, it says that negative b plus or minus the square root of b squared minus 4ac divided by 2a. All right, we have established that in a quadratic formula, the standard form is ax squared plus bx plus c, and it is equal to 0, okay? Or you could replace the 0 with the y. So in other words, you could have as y equals this, basically this is the standard form, y equals to ax squared plus bx plus c. Now on the quadratic formula, the idea is to find the solutions where y is equal to 0. That's why they replace the 0 with the y or the y with the 0. So let's forget about y for a second and let's just focus on this. This is the standard form. And again, I'm going to rewrite the quadratic formula just in case. So the quadratic formula says that negative b plus or minus, y plus or minus, because when you have a quadratic equation, x squared, let's say x squared is equal to 9. So what would be the value of x? 3, because 3 squared is 9. But also it could be negative 3, because negative 3 to the second power is also positive 9. So that's why we have this plus or minus. So plus or minus, and then the square root, okay, you see that? The square root of, and then we write b squared minus 4 times a, and then times c. Everything divided by 2 times the value of a. All right? So now let us start solving equations. And let us take an equation that is easily factor, okay? Factorable. Let's try the equation m to the second power minus 5m minus 14. And that equaling to 0. So it is already solved for 0, so all I have to do is if I was to factor, all I have to do is factor. So no greatest common factor, so I proceed to open the parentheses. Okay? 7 and 2. Okay? And now when I do the smiley face to get the middle term, I notice that 7 has to be negative and 2 has to be positive. In order to get 2n minus 7m equaling 5m. And negative 7 plus times 2 is negative 14. And this equals to 0. So now you set each of the factors to 0. So what value here will give me 0? What value for m? 7. Because 7 minus 7 is 0. What value will give me 0 here? Well, m has to be equal to negative 2. See, if m is equal to negative 2 plus 2 is 0. So these are the solutions. So when you are stating the solutions, you could state them like this. You open the little braces, brace, and you put 7 comma negative 2. You close the brace, and that's it. Okay? Now, we know how to do this by factoring. There are some quadratic equations that cannot be factored. That doesn't mean that they cannot be solved, and that's what we're going to be looking at here. So we're going to take the same equation and we are going to use the quadratic formula. Okay, so let me rewrite the equation again. M squared minus 5m minus 14 equals 0. So the quadratic formula again is right here. It's a good idea to copy it down to have it handy. All right, so let's see what it says. It says negative b plus or minus b squared minus 4ac. So I need to identify a, b, c, and negative b. So by looking at the standard form, we know that a is the coefficient of x squared, b is the coefficient of x to the first power, and c is just the loose number without a variable. So then here we have a being 1, because that's the coefficient of m squared, b being negative 5, c being negative 14, and of course, if b is negative 5, what is the opposite of b? In other words, what is the negative of this? Positive 5. See that? Okay, now I'm ready to start using the formula. So the formula says negative b plus or minus. So negative b, right here, 5 plus or minus the square root of b squared. B is negative 5, so the square root of negative 5 squared minus 4 times a, which is 1, and c, which is negative 14. And everything gets divided by 2 times a, which in this case is 1. See? No letters, no nothing, just pure numbers. Okay, so let's simplify. So 5 plus or minus the square root of, and now let's see, what is negative 5 squared? Correct, it's 25. 25. Now let's determine the sign here. Negative times positive is negative, so this is negative. Times negative is positive, so it's going to be plus. 4 times 1 is 4, okay? Times 14, you're going to have to use the calculator. That is 56. And everything gets divided by 2 times 1 is 2. This is a long process, but at the end, it gives you the right answer. Alright, so bring down again the 5 plus or minus the square root of, what is 25 plus 56? That is 81 divided by 2. Okay, 5 plus or minus the square root of 81 is 9 divided by 2. Okie dokie. Now, and the next problem, I'm going to show you something else. So let's see now. 5 plus 9 is 14 divided by 2. Oh, you know what? Now let us separate this. Now that I'm going to separate this, I'm going to find, remember, the x-intercepts. So I'm going to say x equals to 5 plus 9 over 2. That's what I wanted to show you in the next problem. That I forgot that the quadratic formula should be x equals, x equals, x equals. Okay? So x equals to 5 plus 9 over 2. But also x equals to 5 minus 9 divided by 2. Okay? Remember, it's 5 plus or minus. Or plus and minus. So let's see now. 5 plus 9 is 14 divided by 2 is 7. So makes this answer, okay, x equals 7. And now here 5 minus 9 is negative 4 divided by 2 is negative 2. So once again, we use the quadratic formula and we end up with the same thing over here. You see, the same answers that we got here, we got over here. Alright, let's do the next problem. Okay, the next problem is going to be, and this one is now gonna get a little harder. Okay, so it's going to be, let me see, 2m squared plus 2m minus 12 equal to 0. So the first thing we gotta do is we have to identify A, B, C, and negative B. So let's see now. A, B, C, negative B. Sorry. Okay. So A is the coefficient of m squared, so it's 2. B is the coefficient of the linear term, m to the first power, so that's 2. C is the loose number, negative 12. And negative B is just the opposite of B, so that will be negative 2. Now, see, I'm talking a little faster and I'm going a little faster. So we write our quadratic formula just in case, okay, just to remind you. And you have to memorize it. So it's negative B plus or minus the square root of B squared minus 4AC and everything divided by 2A. Okay, memorize that. Okay, let's start. Negative B, negative 2. So that will be negative 2 plus or minus the square root of, okay, B squared. So that's 2 squared minus 4 times A, which is 2. No, yeah, which is 2. Times C, which is negative 12. And everything over 2 times A. What is A? 2. Okay, now let us do this. I haven't used the calculator that much for this type of problems, but let's see. Now remember, you're finding the x-intercept. You're finding when x is equal to 0. So that's basically the whole idea behind this. So we're going to write x equals negative 2 plus or minus the square root of, okay, the square root of 2 squared is 4. Well, I'm not going to write minus until I figure out what the sign here is. So negative times positive is negative, times negative, positive. So plus, okay, 4 times 2 is 8, okay, and 8 times 12 is 96, I think. Yep, 96. So plus 96 over 2 times 2 is 4. Once again, x equals, you see, it takes a lot of paper, but if you learn this, you're going to be successful. Negative 2 plus or minus the square root of 96 plus 4, or 4 plus 96 is 100 over 4. Okay, I'm going to write over here as well. X equals, okay, negative 2 plus or minus 10, which is the square root of 100, over 4. So I'm going to split it. The next time I'm not going to split it, I'm just going to do the calculation. So this is the same thing as x equal negative 2 plus 10 over 4, and x equals negative 2 minus 10 over 4. Okay, so let's see. Negative 2 plus 10 is 8. Divided by 4? 2. Negative 2 minus 10 is 12. Negative 12. Negative 12 divided by 4 is negative 3. So your solutions are x equals negative 2 and x equals negative 3. As simple as that. Alright? Let's do the next one. And this time I am going to start skipping some steps because I really don't need them. You need them, I don't. Alright, problem number 3, correct? So I have x squared, let me see. Let's try this one. This one is a little tedious. 4b squared plus 8b plus 7 equaling 4. Kobe, what are you eating? Please don't destroy the mail. Oh my god, dogs. Oh, okay, so what's going on here? Remember, to use the quadratic formula, the equation has to be in standard form. This is not in standard form. Look, it's equal to 4, not to 0. So I'm going to make it equal to 0. We already did this when we were factoring. So I subtract 4 from both sides, making my new quadratic equation, 4b squared plus 8b, and then 7 minus 4 is 3. Alright? And now I identify A, B, and C. And negative B if you want to. It's obvious that negative B is going to be the opposite of B. So A is 4, B is 8, C is 3, and negative B is negative 8. And now use the quadratic formula. So negative B plus or minus the square root of B squared. So that will be, what is B squared? Now let's do it. B is 8. So 8 squared minus 4 times A, which is 4, times C, which is 3. Everything divided by 2A, which in this case is 2 times 4. Okay? So let's see now. Negative 8 plus or minus 64. And now negative times positive is negative. Times positive, negative. So minus 4 times 4, 16, times 3, 48. Divided by 8. 2 times 4. Now I have negative 8 plus or minus, okay, the square root of, what is 64 minus 48? 16. Okay. Over 8. And now I'm gonna write, remember, I keep on forgetting this. You should not forget it. X equals, okay? So now let's see. My two roots, I have two roots here, so I'm gonna go over here. X equals to negative 8 plus 4 over 8. And X, okay, equals negative 8 minus 4 over 8. That's the plus or minus the 16. Square root of 16 is 4. Okay, so let's see now. X equals negative 8 plus 4 is negative 4. Negative 4 over 8 is negative 1/2. And here, negative 8 minus 4 is negative 12. Negative 12, okay, over 8. Negative 12 over 8 divided by 4, I get negative 3. Negative 3 over 2. Okay, sorry for the delay. I was thinking about it. And those are your roots. Remember what we say. These are where your parabola touches the x-axis. Okay, let's do another one. Oh, I'm not running out of paper, like if I'm rich, right? Okay, another one. Let's do one more. 2x squared minus 3x minus 5 equals 0. Oh, okay. Kobe, can you stop eating the paper? Thank you. So let us identify. Okay, is it equal to 0? Yes. So now let us identify A, B, C, and negative B. A is 2. What if this term was here and this one over here? It doesn't matter. You should understand that we're talking about not order, but we're talking about the coefficient of the x squared. The x squared was here, then it will still be 2. Okay? Now negative 3 for B, negative 5 for C, and of course the opposite of negative 3 is positive 3. And now we follow the formula. So negative B plus or minus the square root of B squared, which is negative 3 squared, minus 4 times A times C divided by 2A. Okay, and now we have 3 plus or minus. Let's see if we can understand this right away, because the thing is that the less paper we waste, the better it is. Alright, negative 3 squared is 9. Okay, now let's do this. 9. Okay, now negative times positive is negative, times negative, positive. So 4 times, oh, plus, right? 4 times 2 is 8, times 5 is 40. Okay, divided by 4, which is 2 times 2. 3 plus or minus the square root of 49 divided by 4. And then we have our split terms. And remember what I said. X equals, X equals, X equals, and I keep on forgetting. Please, you don't. So now I'm going to separate this, and I have X equal 3 plus 7 over 4. And X equals 3 minus 7 over 4. So we have X equals 3 plus 7 is 10 over 4. If you reduce it, you get 5 over 2. 3 minus 7 is negative 4, divided by 4, negative 1. Making your solutions 5 over 2 or 2.5, and X equals negative 1. I showed you how to do it on the calculator. You could just graph this and you'll see where the parabola touches here and touches here. Got it? All right then. I'm gonna do one more. After the 5th problem, you should master this. So I wanna do something that is nice. We did radicals at some point, but so far all these problems have had nice solutions. I want to try one that it doesn't have nice solutions. Backs. Okay, let's try this one. 2m squared minus 7m minus 13 equals negative 10. I hope you can see from far, because I am actually gonna zoom out. Okay, now this is not in standard form. This is not equal to 0, so I'm gonna make it equal to 0. So I'm gonna add 10 to both sides. Negative 13 plus 10 is negative 3. Now let's identify A, okay, B, C, and negative B. A is 2, B is negative 7, C is negative 3, and negative B is the opposite of B, so that's positive 7. And now let's use the quadratic formula. This term, this polynomial right here, is not factorable. That's why I need to show you what's going to happen. Okay, so negative B, 7, plus or minus the square root of B squared, which is negative 7 squared, okay, minus 4 times A, which is 2, times C, which is negative 3. Okay, and everything divided by 2A. 2 times 2. Okay? Alright. Let's simplify. 7 plus or minus the square root of negative 7 squared is 49. Negative times positive is negative, times negative positive, plus then. 4 times 2 is 8, times 3 is 24. Everything divided by 2 times 2 is 4. Now bring down again. 7 plus or minus the square root of, what is 49 plus 24? That's 73 over 4. And that's what I was talking about. 73 doesn't have a perfect square root. So what you're going to do is the following. You're going to write 7 plus radical 73 over, and the whole thing over 4, right? X equals, I keep on forgetting, sorry, and keep on forgetting, sorry. Okay, you're gonna write this, and you're gonna write 7 minus radical 73, or square root of 73 over 4. Okay? And this is the deal, guys. Since 73 doesn't have a perfect square root, what we do is we try to simplify, okay, the rational. Like, for example, and I'm gonna give you an example right here on the side. If you wanted to simplify radical 50, all you have to do is find two factors. One being the biggest perfect square, like 25, and the other one being the lowest number that cannot be simplified anymore. So 25 times 2 is 50, so this is radical 50. Square root of 25 is 5, and square root of 2 doesn't have one, so it stays as 5 times radical 2, 5 radical 2. That is radical 50. That is simplifying radicals. In this case, 73 is a prime number. You cannot simplify it into factors. So your answer remains like this and like this. Now, if you ever are solving a problem that has to do with money, distance, or they ask you to please round to the nearest tenth, then, my friends, you're gonna have to use the calculator. Okay? Use the calculator and you find out what the square root, okay, what the square root, you see, second x squared, what the square root of 73 is. It's 8.54 blah 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 blah. So then this would turn into 7 plus 8.54 divided by 4, and this turns into 7 minus 8.54 divided by 4. You do that and you're gonna get a number. So those will be your solutions if you want to do decimal numbers. If they don't ask you for that, if they say in simplest radical form, then radical form. This is radical form. All right, got it? You want me to do another one that has to do with radicals? Okay, let's do another one. Whew. I need paper. Ouch, sorry. Ouch, 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 ouch. Paper. All right, so let's have this one. This one is a beautiful one. All right, so this is number 6, I think. So we have 9n squared, okay, equals 4 plus 7n. All right, I will not continue talking. You should know what to do, or you should know at least what I'm doing. And that's it. 193 cannot be simplified, and 193 doesn't have a perfect square root. But once again, if they ask you for the decimal value, then you put this in the calculator, you get your number, then you put 7 plus whatever. Or you could actually put the whole thing in the calculator. Ooh, like a tire. It's midnight. So you could put the whole thing in the calculator and you get a nice number, a decimal number, and you put it in there, and those are your solutions, okay? So I hope you had enough of this solving quadratic equations by using the quadratic formula. And I'll see you in the next episode of How Do We Pass Our Common Core Algebra Regions. And we are going to be using a method called completing the square and still solving quadratic equations. Okay? Alright, bye. Alright, so now we are going to solve quadratic equations. Okay, solving quadratic equations by completing the square. So what I need you to do right now is I need you to copy these 6 steps. Okay, these are the 6 steps that we are going to use to solve quadratic equations by completing the square. So pause the video, copy, and then we'll move on. Okay, so I hope you did copy, and now let's start. Let's start with an easy equation, okay? So let's have the first one. A squared plus 2a minus 3 equaling to 0. Alright, so the first step is to move the constant term to the other side. So that's what we're going to do. A squared plus 2a, and then look at this. We're moving the negative 3 to the other side. In other words, we're going to add 3 to both sides. So then the 0 plus 3 is 3. So far so good? Okay. Now, hope you can see it right there. Now we are going to divide everything by the coefficient of x squared if the coefficient is greater than 1. Here the coefficient of the square term is 1. So we don't need to divide, but let's see, because if we divide by 1, we're going to end up with the same thing. You understand that? Cool. Then the next step is take half of the linear term. So on the side right here, I'm going to do it. The linear term is the term that has an exponent of 1. So this is the coefficient of the linear term. So we're going to take half of 2. You could do the following. Take half, in other words, multiply by 1/2, or you could just divide by 2. Okay? So we take half of the linear term, and then it says square it. 1 squared is still 1. And then it says add it to both sides. So I'm going to add 1 to both sides. See that? Now, as soon as you do that, it automatically turns into a perfect square trinomial, meaning that I can actually turn this into a square binomial. So let's factor this. Three plus 1 is 4. Okay. So let's see. Factors of a squared, a and a. Factors of 1, 1 and 1. If I do the smiley face, how do I get 2? Plus 1 plus 1. See that? And now, of course, you're not going to leave it like that. In future problems, we're not going to be doing this. We're just going to do the square binomial. So a plus 1, a plus 1. So that means that this is a plus 1 to the second power. And that is equal to 4. Then the next term says take the square root on both sides. See that? Okay, what is taking the square root going to do over here? Well, the square root is the inverse of squaring a number. So in other words, the square root and the square cancel out. So what does it leave? It leaves with a plus 1. And now, my friends, you're going to learn something. The square root of 4 is not just 2. 2 squared is 4, yes. but also negative 2 to the second power is also positive 4. So that means that the square root of 4 is positive or negative 2. Okay, it's always the case. Now we solve for x or whatever the variable is that you have. So in this case is a, so we solve for a. How do I solve for a? Subtract 1 from both sides, right? So what do I have? A equals to negative 1 plus or minus 2. Last but not least, we have two solutions. A equals to negative 1 plus 2, and we also have a equaling to negative 1 minus 2. Negative 1 plus 2 is 1. Negative 1 minus 2 is negative 3. And we found our solutions. So this is how you solve quadratic equations by completing the square. Alright, let's do one that is not so obvious. Oh my god, you see I cannot write in here, so I'm gonna have to use another, oh my god, a piece of paper. Alright, no way. Okay. Alright, let's have the next one. What's the next one? Alright, so let's try one where the coefficient of x squared, or you know what? Now let's try another one. It doesn't matter. P squared plus 16p minus 22 equals 0. Alright, so this one is already equal to 0, so we got you with that one. Now let's follow the steps. So move the constant, 16p. Okay, now we're talking. Move the constant term to the other side. So we have p squared plus 16p, okay, equaling positive 22. Because we had negative 22 here, we put it on the other side, it changes sign. If you don't understand that, then you add 22 to both sides. So this cancels out, and 0 plus 22 is 22. Now we're going to divide by the coefficient of the square term if it's greater than 1. Well, this one is 1, so we're good, because if we divide by 1, we still get the same numbers. So then the next step is to take half of the linear coefficient. So I'm going to put it over here. So half of 16 is 8. Okay, and then it says square it. So 8 squared is 64. Okay, and we add it to both sides. So we have p squared plus 16p plus 64 equals 22 plus 64. Huh? Whew. Now by doing this, we create a perfect square trinomial. Meaning what? Meaning that this will turn into a square binomial. So let's factor. Okay, so we're still doing step by step, and I said in the future I'm not going to do it. Alright, what is 64 plus 22? That's 86. Yes? Alright, now let's factor. So p on both, 8 on both, because that's what happens. So now I need a positive 16, so plus and plus. And now this turns into a square binomial. There you go. Equaling to 86. The next step is to take the square root on both sides. But before we take the square root on both sides, I want to clarify something. When you turn this into a perfect square trinomial, and then you're going to turn that into a square binomial, think about it. What was that number that you took half of? You took half of 16, and that gave you what? The 8. And look at coincidence, right? The number that you square is the number that when you add it, when you double, you get 16. Double of 8 is 16, and square of 8 is 64. So right there, that should give you the cue of how to turn this into a square binomial without going through the factoring phase. All right. Anyways, the next step is to take the square root of both sides. So I'm going to take the square root on both sides. So I get, you know what the square root does? It cancels the squaring. So that leaves you with p plus 8 equaling to plus or minus. Remember, the square root, it has to be plus or minus. 86. Oh my God. Can I actually do 86? Let me see. 86 divided by 4? No. 86 divided by 9? No. 86 divided by 16? No. 86 divided by 25? No. 80, and you know what? That's it. You cannot do anything else. Alright? So that means that 86 cannot be simplified as a radical. So it stays as radical 86. The last step is to solve for the variable. So p equals, what am I going to do here? I'm going to subtract 8 from both sides. So by subtracting 8, I cancel this out. And on the other side, I get negative 8 plus or minus the square root of 86. Your roots are going to look like this. Your solutions. Negative 8 plus square root of 86. And also, p is going to be negative 8 minus radical 86, or the square root of 86. Now, if they were to ask you to actually leave it in decimal form, then fine, use the calculator. Put this in the calculator and you're gonna get, let me see now, square root of 81 is 9. So this is gonna be 1.273, okay? And this one is gonna be negative 17.273. If you don't believe me, just do it. Okay? So radical form, decimal form. Let's do another one. In this case, I'm going to use the other half of the paper because I'm running out of paper. Okay? Let's do another one. Let's do one that is also not so friendly. So I want to do okay, m squared. No, I want to do one that really doesn't have let me see, I want to do one that doesn't have a coefficient of 1 so you could see what's going on. Okay, good. Let's try this one for size. 5v squared minus 21 equaling to 10v. Okay, we're gonna do that one. Let's see what happens when I do that. So move the loose number to the, first of all, it has to be equal to 0 in order for me to start doing anything. So I'm gonna make this 0. So 5v squared minus 10v, because I subtracted 10v from both sides and this canceled out, minus 21 equaling to 0. Okay, now everything is equal to 0. Now let's talk about it. Move the constant term to the other side. So 5v squared minus 10v equals positive 21. Okay? Now divide by the coefficient of the square term. So I'm going to divide everything by 5 because now this one is not just a 1, it's a 5. Okay, so what happens? Well, this one turns into v squared. That's the idea, to make the square term coefficient 1. So v squared. Now negative 10v divided by 5 is negative 2v. And then you have 21 over 5. Not so nice, right? Doesn't matter. The next term is take half of the linear term, okay? Square it and add it to both sides. So this time you could write it down if you want to. So half of negative 2 is negative 1. You know, let me put it over here. Half of negative 2 is negative 1. And when I square negative 1, I get 1. So that's the number I'm going to add to both sides. Plus 1. Remember the requirements of a perfect square trinomial. The last sign is a plus. Equals to 21 over 5 plus 1, because you got to do it to both sides. Okay. Let me make this a little friendly. Okay, you could always do it on the calculator, but let me make it friendly. So this turns into v squared minus 2v plus 1 equaling 21 over 5 plus 5 over 5. The 1 turns into 5 over 5 because I need the same denominators in order to do something. Okay, now we're talking. So remember what happens when you take half of the linear term and square it? You create a perfect square trinomial. This time I am not going to factor this into factors of v squared, v and v. No, that's it. I'm going to go straight into the square binomial. So I know that the first one is going to be v. Now, all you have to say is, what was the term that I squared? U squared negative 1. U squared negative 1. So then that's the number that's going to be here. Now that's your perfect square. Square binomial. 21 over 5 plus 5 over 5 is 26 over 5. Okay? And now, the next step is to take the square root of that. So, square root of v minus 1 squared and square root of 26 over 5. Okay? Then when they take the square root, they cancel out. So that's v minus 1 equaling to, okay, plus or minus the square root of 26 over 5. Now you solve for v. So v is equal to 1 plus or minus the square root of 26 over 5. Okay? Now, of course, this turns into 1 plus the square root of the ra and 1 minus the square root of the ra over 5, right? So then, making your solutions the following. 3.28 and v is also negative 1.28. Okay, you put that on the calculator, first with the plus, then with the minus, and you're gonna get these two solutions. Okay, and that is how you factor. That's how you solve quadratic equations by completing the square. You want me to do one more problem? Not a problem. Not a problem. I'll do one more. Let's try this for fun. This one is not so bad. 2n squared plus 12n plus 10 equaling to 0. All right. So this one, you try it, pause it, try it, find the solutions, and then we are going to confirm that you got the right answer. Okay, so now that you solved it, let's see what's going on. So, is it equal to 0? Yes. So I don't have to do much. Now, I just have to follow the steps. Move the loose number or the constant term to the other side. So it changes sign, right? Then divide by the linear coefficient. Is greater than 1? Yes, so I have to divide. So let us divide by 2. So divide by 2, the whole thing. So you end up with n squared plus 6n equaling to negative 5. Now we take half of the linear term and square it. Half of 6 is 3, square 9. And you add it to both sides. Now this creates a perfect square trinomial. That means that I can turn it into a square binomial. Okay, so n goes here. Now what was the term that we that we squared? The term that we squared was positive 3. See that? So double of 3 is 6 and square of 3 is 9. Negative 5 plus 9 is 4. The next step is to take the square root of that, right? So take the square root of that. So n plus 3 equals to plus or minus 2. Then we solve. So we subtract 3 from both sides and we get negative 3 plus or minus 2. So we get n equals to negative 3 plus 2 is negative 1. And negative 3 minus 2 is negative 5. Okay? So sometimes it will be nice, sometimes it won't be nice. As long as you follow those instructions, you'll be good. So now I'm going to give you problems to do. So solve by completing the square. So this is how you're going to do this. So you have 4v squared plus 16v equaling 65. Solve it. And the other one that I'm going to give you is going to be n squared, okay, plus 19n plus 66 equals to 6. Okay? So do it and then we check the answers. And this concludes our session on solving quadratic equations by completing the square. So far we done it by factoring, by using the quadratic formula, and now by completing the square. Okay? So I think this was the last method. On the next episode, we are going to go back to the quadratic equations in terms of graphing them, and we are going to explore a new way of finding the axis of symmetry and the vertex. Alright, so until next time on how do we pass our Common Core Algebra Regents. Bye bye.